Greetings, everybody. Massive Palkumar part. Let me ask you something. What if I give you a sentence and ask you to check if all the characters present in the sentence matches all the alphabets present in the English language at least once? Will sound simple, right? But it's much more complex than what you think, because it's probability that the solution that you will try to solve this problem will not be the best optimized for 80% of the times. Yes, welcome to the lead core problem solving series. Today we are going to solve the problem, check if the sentence is pangram or not. We will start by understanding the problem properly, then go for the most brute force straightforward approach, and then go for the most optimized approach for solving this problem. So let's start by understanding what the problem is trying to say. We are simply given a sentence in the form of a string, and we need to check if all the characters present in the sentence contains all the alphabets of the English language at least once. It can be more than once too, but we need to check if it contains at least once or not. If all the alphabets are present at least once in the sentence, then we will return true, otherwise we will return false. That's our simple task for this problem. Let me give an example. For example, we have the sentence, the quick brown fox jumps over the lazy dog. Then you can check each and every alphabet from A to Z in the English language are present in this sentence from start to the end at least once. Also, we have given a constraint that the characters that we will be checking, the alphabets, they will be lowercase only. No uppercase characters are involved in this complete problem. So you can check in this sentence, every character from A to Z are present in the complete sentence at least once. So thus, for this test case, we will return true. For example, we have another test case called lead code. Obviously, you can see its length also didn't reach to 26 characters. So it's obviously not containing each and every character of alphabets. So we'll simply return false for this test case. This is a simple task. Let's go for the most brute force straightforward idea that we get for solving this problem. Okay, so now you know what our task is. We just need to check if every character is present in between A to Z, then we will return true. If any one is also not present from A to Z, then we will return false. Okay, for that, the most straightforward idea that comes to my mind is that we will need at least two loops, that two nested, because one, the outer one for checking if for like iterating from A to Z, because obviously we need to check for each character by going from A to Z. Like, I hope you what I'm trying to say you understand. We will take one character, we will go from A to Z and check if it's present or not. Yes, then next character A to Z, next character A to Z. Like, we are iterating from A to Z again and again. So for that, we will read an outer loop where we will start from A and we will go till the last character of alphabets called Z. Okay, simple and sorted. Here it will be character because the variable is char. Okay, so outer loop for that part. Now we will use an inner loop for iterating through each character of the sentence. As I mentioned, for taking the character, we will need inner loop. For that, let's go for the internal loop where we will start. Here it will be end because we are gonna use index of the string. Okay, it will be j. Yeah. So from starting index to the last index of the sentence, which will be sentence dot size. Okay, so we are iterating from the first character to the last character, and now inside this we need to check if the character that we are on, if it's present between A to Z, then we will just break the inner loop, because we know that yes, it's present. and if it's not present, then we will return false on the spot. Okay, so let's check. For that we will be needing a boolean variable to check this if it's present or not. So two values, true or false, simple. We will declare one a variable which we will name as found. Okay, which we will set to false for the start. For gaining a start we will set it to false, obviously, and then we will check if the sentence, okay, is sentence of starting from the first character is equal to, we can say, the I. Okay, here it will be J. Okay, the character of in the sentence, if it's equal to I, then we will set found as true. Okay, simple and sorted. If the character that we are on, if it's present, like if it equals to A to Z, any character from A to Z, then we will set the variable as true, and if it doesn't match, then we will set it as false. Okay, so again, after the inner loop we will check that if found is, here it will be if, okay, if found is still false, obviously for checking boolean values we just don't need to set anything, but then we have false, so we will need it. So if found is equal to false, we will just return false on this part itself. Otherwise, inside the if anything matches, then we will just break, because we don't need to check now that if it's present or not. Okay, so we will break in the inner loop, and then after the inner loop we will check if the found is still false, then we will return false. Otherwise, at the end of the loop we will return true. So using this code, we are simply checking one by one, brute forcefully iterating from the start to end again and again, to check if the character that we are on is present between A to Z or not. If it's completely perfectly working, then we return true, otherwise we return false. Let's check if this works or not. Okay, so yes, it works. It perfectly works. Now let's check if there is any edge case by submitting the code. So yeah, it perfectly works. As you can see, the complete brute force approach properly works from the start to end for all test cases present in the complete problem. So as you can see, this is the most brute force approach, that we are iterating one by one through each and every character for each and every inner character too, which is obviously too much redundant because it's not going to work for bigger test cases. Obviously, the when we submitted, it gave 100% accuracy, because it's most of the solutions are mostly equivalent to this one only, the brute force one. But in real life it's not going to work, because for too much big test cases, for too much long sentences, we can't use this way nested loops to check if the character that we are on is matching from A to Z or not. This can't work, you also know that. Okay, for that thing we need an optimized solution. Okay, so let's go for the most optimized approach. Let's think what can we do to gain, like to reach for an optimized approach. I think the most optimized approach that we can use here is that currently what we are doing in the brute force one is we are taking a character and then we are going from A to Z if it's present or not. So like we are iterating from A to Z again and again. We are passing the character that we are on from A to Z from start to end again and again, which is redundant. So we'll just reduce this process, that instead of passing the character from A to Z again and again, we will store A to Z somewhere in, for example, any type of hash based structure for making it more easier. And then we'll just check if the character that we are on, if it's present, like it matches, then yes, we will return true, otherwise we will return false. This is the basic concept of what will be our optimized approach. Obviously now we can use any type of hash based structure, we can use set, vector, map, anything. But in my point of view, we just need to go, like we just need to return true or false for these type of small returning values. In my point of view, using vector is the most best approach, so we will go for vector 2. At the end we will also check if there are any other approaches too, by just mentioning that. So the idea actually is that we will store a to z in a vector in form of indices, like from a starting as 0th index until 25th index, we can say representing the 25th index representing z. So like that we will store each and every character's presence in the array. What we will be doing is that we will start from the first index of the sentence and we will go till the end of the sentence, and we'll check that if the character that we are on, if it is present between a to z, then we will store that characters, like that alphabet's value, as true in the vector. Let me show you by writing that. Okay, for that we will need a vector which will contain character values. No, it will be containing boolean values, because as I mentioned, we will set true or false for all the alphabets, so it will contain boolean values. And let's name it as check. The variable will be check. And obviously for starting the approach, we will be having 26 elements in the complete vector from a to z. And for now, for starting the approach, we will set all the values as false, because we haven't started checking from the starting index, so we haven't checked if anyone is present or not, so everyone is set as false. Okay, for starting the approach. Now what we will be doing is completely simple. We will iterate through each and every character s, for example s, in the sentence. We will iterate through the complete sentence, every character, and we will just check that if the s is between a to z. Okay, if it's between a to z, then we will set that alphabets, or we can say that character's value, as true in our vector. So check of that s will be equal to true. Okay, so check means inside the that vector we will set that character's value as true. Okay, a simple and completely sorted. For reducing this if to, we can do one thing more, like one more optimized way of writing this complete if. Okay, we can, what we can just do is that we can write it in a single line. Check of that, we can say like we can write it as s directly, that s, that character, minus the 0th index value. Okay, I hope you will be understanding what I'm writing here. What I'm just doing is that I'm setting the character's value by minusing 0th index, like by subtracting 0 from the alphabet's place value, and then storing that place values, we can say representation, that place values presence, as true. Like let me give an example. If we are starting with the 0th index t, okay, so what I'm doing is that inside check we have t equal to false, because we are just starting. So what we will do is t, like s t, here it will be t, let me write it as t, t minus a, which is 0, means t's place value, which is around 20, t's place value in alphabets is 20. So 20 minus 0, which is 20 equal to true. Which what it will do here is it will set check of 20 equal to true. Okay, means the 20th index of check will be equal to true. Which what will it do? It will mention that yes, one character that in the sentence equals to t, which is an alphabet. So we will now have t at least coming once in sentence. Like we will know that yes, t at least came once. T is here with us, so we will set it as equal to true. Like now we know that yes, t is present in the sentence. We don't need to check if t is present or not. We will just set it as true. Okay, simple and sorted. I hope what I'm you understand what I'm trying to say is okay. So like doing this, we will go from start to end of the sentence, and we will also check with that if it's present between a to z, that a character's index will be set as true. Okay, after this, after the completion of this loop, what will happen is that in the complete check named vector, the character or the alphabet which is not present in the sentence, it will still be as false. Because just simply think, for example, w is not present in our sentence named string, then w will not come in this complete line. Okay, so check of w's place value. Now wxyz means it's 22, which means that check of 22 will still be present as false after the completion of this loop. Okay, I hope what you understand what I'm trying to say. That alphabet's value which we haven't visited till now in this completion of loop, it will still be false because we haven't visited that alphabet, and we don't know that we actually know that yes, it's not present in the sentence, so it will still be false. Okay, simple and sorted, understood. Now after this, what we have is we have a vector which contains the answer of yes, this alphabet is present or not, true or false, simple, as with the representation of its index. So now what we need, we will iterate through this vector and check, simply check that if any element of this complete vector is false, single element too, return false on the spot. Okay, because we know that yes, if any element in the vector is false, we know that yes, this at least one alphabet is not present in the sentence, which we need to check. So we'll return false, simple and sorted. So what we'll do is we will iterate through the complete vector. Okay, for iterating through the vector, what we'll do is we will iterate like this way. Okay, for iterating through vector, we will just write the index from the starting index to the end index, which will be like check or dot size. And for that part, we will just check that if check of that I is equal to false, then completely return false on the spot. Okay, we have the answer that yes, if the presence of any alphabet is still false, then that alphabet is not present in the sentence and we need to return false. Simple. After the completion of this loop, we know that yes, it hasn't returned false any time between the complete process, the complete loop. So we know that yes, every alphabet in the English language is present in our input given string. So we will return true. If it works or not. Okay, yeah, it works. Let's check for the edge cases. This is the most optimized solution. I will also mention why. Okay, as you can see, the complete approach is submitted now, and now let me mention why this approach, this complete approach, is most optimized one. Okay, many of viewers will be thinking that we also have better approaches too. There are other approaches possible too. Let me show you possible. Okay, what we can do is starting from the first approach, apart from this complete approach, we can also do these approaches too. What we can do is we will just declare a set. We will store every character from the sentence string in the set, because you know that set will only contain unique characters. So if any character in sentence repeats, it won't be stored in the set. So every after storing every character in set, we will just check the length of the set, because we know that yes, every character after storing the sentence inside set, we will just check that yes, if the set's length is equal to 26, which means every character inside the set is unique, which means it's present between a and z only, which tells us that yes, every alphabet is present in the set. If yes, we will if it's equal to 26, we will return true, otherwise we will return false. Now why this is less optimized than this one, I will mention that too. Okay, for storing in set any character in set, for storing that in a set, the for single character the time taken is equal to order of log n. So for every character of a sentence storing that in set, the time we will need is order of n log n. And for vector, for storing every character in a vector, we need order of 1. Like we will take the time as order of 1. So for every character, the time taken will be order of n. Now you know that order of n is less than order of n log n. So this one is completely optimized than this complete set approach. Okay. Now moving to the next approach. Many of you would be doing like they will be creating a frequency array. What frequency array does? We will create an array and we will store the frequency of every character from the sentence. Like we will store how many times a character comes, and then we will again do the same thing. We will check the length of the array if it's present or not. But again, for storing in array, the time taken is almost equal to n log n, and it is again not optimized as much as the vectors approach, as you can see. Okay, it is also see, now you will be telling that yes, the difference of optimization is too much low. You are correct, but for the video I need to mention only the most optimized one. So the most optimized one is this one. So for that thing I mentioned that. Otherwise we have these approaches too, these main three approaches. Okay, these are also bit less optimized, but they are also approaches for this solving this problem. The last approach is that what we'll do is we will iterate through the string, we will sort them, and we will remove the duplicates, and again we will check the length of the string. If it's equal to 26, then yes, we will return true, otherwise we will return false. Simple. These are the other approaches other than this approach, but this one, as I just mentioned, it's the most optimized one. So this was the complete solution of the check if the sentence is panagram or not. If you have any doubts, you can mention in the comments, or you can connect with me personally too by using the social connections link present in the description of the video. If you have any feedback or any positive feedback too, you can mention that in comments, or you can again connect with me too if you want to mention that personally. If you also want these type of tech related, coding related content, you can subscribe to the channel and stay along with me for getting more these type of better content. Thank you very much for seeing the video. Thank you.